Hand in there. All right, so this is going to be our first in-class practice for acceleration. And so we introduced acceleration yesterday. And we said that it is velocity divided by time, all right? And so if we have to use this extended version, it's because the initials are not zero. So like if my initial velocity is anything besides zero, then I need to use this. If my initial time is anything besides zero, I need to use this. Because if you subtract zero from these, it's just your final. So really you don't have to do that whole subtraction step. And we can just use the simplified version, all right? We do have a triangle, works just the same. You might, on your paper, want to put, oh gosh, my calibration is way off. You might want to put, that little division symbol there. And that way, you remember that going, up and down is actually division. And that side to side, the acceleration multiplies by the time if you're solving for velocity. All right, let's see if this is still. It's a little off. Okay, so you might want to add that on your paper. So just like we've been doing, we're going to circle what we're solving for. We're going to underline the information that is given. This might be where you have to decode a little bit. If it says starts or begins, that should key you in that is an initial value that it's giving you. If it says something like it stops or ends, then that's going to be talking about one of your final positions, right, or final values. So just make sure that you're paying attention to some of those keywords, and it should help kind of make this a little bit better. Okay, notice on the side, now we have 1, 2, 3, 4, 5 variables that we might be dealing with. Most of the time, the initial velocity and the initial times are going to be zero, but you have to look at every problem just to make sure that they're not something other than zero. Because sometimes the velocities you'll have 2 velocities, but most, 90% of the time, you're only going to have one time given, and the other one's always going to be zero. Okay, so it says a car's velocity changes from 45 meters per second to 85 meters per second in a period of 45 seconds. What is the acceleration? So Brady, what am I going to need to circle? What am I solving for here?
Acceleration.
Okay, so that's what we're going to need to circle. So remember, whatever I do on my paper, I would like you to do on yours, please. All right? Kendall, give me another piece of information that's given. Okay, and what is that? Well, we'll hold off on that. Can they give me something else to underline?
The velocity, the car's velocity changes from 45 minutes per second.
Okay, 45, if it's minutes, it'd be MIN, so meters per second. And then, Maddie, give me the last piece of information to underline.
85.
Very nice. Now, I have these things, so acceleration becomes my question mark, okay? From there, I need to figure out, okay, what exactly are all of these things? I think picking out time is the easiest one. So, Nevaeh, which one is time out of these 3 that I underlined?
4.5 seconds.
Okay, so that is my time. Now, do we see 2 times? No. So the initial time, I don't see anything, right? It says for a period of 4.5. So that 4.5 is the ending time. It's like I hit the stopwatch and 4.5 seconds went by and then I stopped it. Started at 0, ended at 4.5. So the 4.5 is really my TF. All right, so now we're down to our velocities. Which one do you think we started with? Which is going to be our VI, Garrett?
45 meters per second.
Good, that's going to be our initial. So you go from 45 to 85, and so the 85 is where we end. Alright, so my equation, and again, when it says use the triangle, it doesn't mean you draw, thank you, you can just put it on my desk. It doesn't mean you redraw the triangle, it means you use the triangle, right, of velocity over time, right? Remember, this change of velocity is really VF minus VI, and this T is really TF minus TI, if you need them. So if we are using VF and VI, this one is not zero, we need the extended version. So this is gonna be VF minus VI over, and then since this is minus zero, we can just make this our T. If you would prefer to do TF minus TI to keep it consistent, you're fine with that. But once you realize that subtracting by zero is just your TF, you can put that. So now we have everything identified. We have the equation worked out, or identified here. And now we just start plugging in. So we're gonna put in 85 minus 45, and we're gonna put that over 4.5 minus 0. So we have a couple stages, right? We need to do our subtractions first and then come back to division. So 85 minus 45 is gonna be 40, and then 45, or 4.5 minus 0 is just 4.5. And so when we simplify that, what do we end up with? Brady, what do you have?
8.88888.
Okay, so we could go 8.9, we could even go to 9. This is just calculation practice, so I do not care how you round. Yesterday on the lab, I was very specific how I needed you to round, because if you rounded to the whole second, it might not have been specific enough. Okay? So we end up with 8.9, and now we need to look at units, right? And so I'm gonna mark where they came from. So these are the meter per second, and these are the second. So it's like a meter per second over a second. This actually means squared. So you end up with a meter over a second squared. And really with acceleration, we know it's vector, but if it's a positive acceleration, that is the sign that's included, that's the direction. And so obviously you don't have to put a plus sign. If it's a negative value, then you 100% need to include that negative, because that is like the direction. But for this, like, you don't have to say 8.9 meters per second west. If a direction's given, then you can put it. But more for acceleration, it's having that minus sign included when you need to include it. So it's just like one step more than our speed and velocity equation because of these final and initials. Okay? Make sense? Okay. Let's go to number 2. All right, while traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. What is the car's acceleration? And remember that a negative value indicates a slowing down or a deceleration. So Caden, what are we solving for? Okay, so that's what needs circled. And that is my great unknown, or my question mark here. So let's start underlining. Give me something, Kenna.
It slows down from 24 meters per second.
Okay. So when I see this, I see that 24 is where I started. It starts at 24. So that's really my initial velocity, right? And I can see that because that meter per second is telling me velocity. So sometimes with these, I like to kind of code it right above it and then fill it in over here. If that's something that you think is going to be helpful to you, go ahead and do it also. Layla, what else should we underline? Good. And so that's going to be a velocity, and that's where it ends, right? So notice these aren't saying it has an initial velocity of 24 meters per second and a final velocity of 15. You have to decode that. Okay, you have to interpret that. And then what, does anybody see Connor Howard today? I was gonna say, I just realized, like, he's not on my list.
Yeah, I saw him this morning. Yeah, he's here, I don't know when he's here.
Okay, I will call. Connor, what else do I need to underline?
12 seconds.
Okay, and then, do we see 2 times? I don't see 2, so the initial is gonna be 0. And again, most of the time, the initial is 0, so if it says it took 12 seconds, or a period of 12 seconds, or it lasted for 12 seconds, you go from 0 to 12. Alright, so our final time is 12 here. We said the initial is gonna be 24, and that the final was 15. So we're still gonna use the same equation that we did, because we need to use the extended version. And now I just start filling in. So my final velocity was 15, my initial was 24, my time was, and this time I'm just gonna put 12, because I know that that's like, you know, I could put 12 minus 0, and if that makes you feel better, like, so you know where it's coming from, go ahead and do that. But if you feel comfortable that that's just 12, that's fine too. All right, so now let's do 15 minus 24. What do you get, Garrett?
-9.
I'm so glad you included the negative, right? It's -9 over 12. And so now we go ahead, you can, it makes more sense to actually do that division. If you would leave it as a fraction, that's not as accurate. So try to just go ahead and give me a decimal answer there. I know one thing. Okay, 0.75, and I'm gonna need to make sure I include that negative. So I'm gonna have negative 0.75. And then I need to make sure I include my units. Again, these units are still the meter per second, and my time is still a second. So this becomes a meter per second squared. And that negative includes my direction. So it could be down, south, left, west, backwards, reverse. But really, logically, we know it means it's slowing down. Okay? So good? An ant sees a crumb and starts moving at a velocity of 4 centimeters per second. The ant speeds up to 8 centimeters per second and is accelerating at a rate of 2 centimeters per second squared. How much time will it take for the ant to reach the crumb? Okay. Dane, give me something. What are we solving for here?
The time.
Very good. How much time will it take? So, what do you think our initial time is?
0.
It's going to be 0, right? So, we want to know the period of time. How long did it last? So, we're really concerned with just that final. So, that is my unknown. All right, give me something to underline. Let's go with Andy.
4 centimeters per second.
Okay, and that's a velocity, right? It says it starts moving. So is the 4 centimeters going to be your VI or your VF? What do you think? Yeah, it's going to be our initial, VI. All right, Egypt, give me a piece of information to underline.
2 centimeters.
Yep, per second squared. It says it's accelerating at a rate of 2 centimeters per second squared. So what is that 2 centimeters per second squared? What do you think, Ethan?
Acceleration.
It's going to be the acceleration. So we can fill that in. That square is also a really good indication. Remember I said whatever you see square, that is representing acceleration. Got another one? Okay.
8 centimeters per second.
Good. And so that's where it's ending velocity, making that the final. So now I can just fill these in. 8 is my final, 4 was my initial. So now I need to set this up for time, right? I can do TF minus TI. Do you want me to show you that way? Or are you good with realizing if you're minusing 0, it's really just T? You guys tell me. Do you want to see it, TF minus TI? Everybody feel okay with that? Okay, so if I have my triangle, since I can't see mine, I'll put it up here. Alright, so this is going to be our division, this will be multiplication, and we have V, A, and T. So if I cover up my T, what am I going to have for my equation? What do you think, Kate?
Velocity divided by acceleration.
Good, and remember, this can really be like our VF minus VI, and this T could really be TF minus TI if I need it. All right, so Kate says we're gonna have VF minus VI over acceleration, which is correct. So now I just fill stuff in. This is, oops, not acceleration, sorry. It's gonna be our T. T equals VF minus VI over acceleration. All right, so now I just fill in my F, which is 8 minus 4. My acceleration was 2. And so if I kind of come over here, because I keep running out of room, what do we get? We get 4. 8 minus 4 is 4 over 2. And that gives me a time of 2. Anybody not clear? We get 8 minus 4 over 2. Simplify our subtraction, then do our division. What time unit do you see in this problem? Just time by itself, Garrett?
Second squared.
Okay, let's drop the square.
Second.
There we go. S or SEC. Here's why it actually does this. Whatever you do your numbers, you do your units. So if this is a meter per second, acceleration, that's all over a meter per second per second. So the meter gets away, the S gets away, and you are left with your additional second over there. So again, if that blue confuses you, you don't have to write that part, but you take the meter per second and you take the meter per second squared, and when the meters cancel out and the 1 second cancels out, you're left with that extra second that had gone with the acceleration. So the math proves why the seconds go with the 2. Yes? With me? Okay. Appreciate it. Got a couple nods, a couple thumbs up. You guys are quiet. Sometimes I don't know if you're just pouting, sleeping. Okay, let's look at number 5. All right, number 5. A motorcycle travels at 25 meters per second and it accelerates at a rate of 5 meters per second squared for 10 seconds. What is the final velocity of the motorcycle? All right, give me something, Garrett.
45 meters per second.
Okay, and so what is that?
Initial velocity.
Okay, that's very good, because sometimes people will see accelerates and they're like, oh, it's accelerating for 25, but there's no square here. So this lets you know that this is going to be just a velocity. So here, I don't have these coded on there already for you. So you have to make sure we have those written in. And Garrett correctly said that this is 25. What else is given in this problem, or what are we solving for? Either way, Kenna?
For the final velocity.
Good. So that becomes my question mark. right? And we haven't done one of these yet. Echo, give me a piece of information that's given. There's two left, give me one of them.
10.07.
Okay, and what's that gonna be? Is that gonna be, a time or an acceleration? Okay, and again, I don't see anything where I'm given 2 times, so I'm assuming that that time is gonna be my final time, and that my initial time would be 0. It will be very clear if you have an initial time. It'll say you start at 5 seconds in and go to 20 seconds in, or something like that. What's the last one?
Accelerates at a rate of 5.0 meters per second squared.
Good. So 5.0 meters per second squared. All right, so now we're solving for velocity. So we're gonna have to do the VF minus VI, which is fine. We still just cover up velocity. And what's it tell us to do?
Multiply.
Okay, so we're gonna take our acceleration times time. People get in such a rhythm of always dividing. And I saw this on your other paper. I was holding off to, I still had a couple people that needed to turn it in that had been absent. So that's why I haven't returned your speed and velocity papers yet. I apologize. I think I'm just gonna give up and give them back to you because there's some things I'd like to go over, which this is one of them. A lot of times people just wanna keep dividing, even though when you set it up, it's telling you multiplication. You just get in that habit of, because 2 out of the 3, you're dividing. So now we just plug in. VF, we still don't know. VI was 25. Acceleration is 5. And time is 10. So I need to simplify. So VF minus 25, what's 5 times 10?
50.
Okay, so I start there. How do I get VF alone? What can I do? What do you think, Dane?
Add 25.
We're gonna do the inverse of subtraction. The opposite of that, or inverse, is addition. So if I have minus 25, I'm gonna add 25 to both sides, because that's the rules of algebra. And this is the most common step that people miss. So I end up with VF equals 75. You subtracted 25, so to get rid of it, add it. And whatever you do to one side, you do to the other. So sometimes people forget they only add the 25 on this side, and they'll have VF equals 50. Right? You have to add it to both sides. So then we end up with 75, and then we already had units for the first velocity, so you can just steal those. Right? This is not homework. Keep it, bring it tomorrow, and we will finish it up. It is not something you need to do on your own. We'll do it tomorrow together. Okay? Have a good rest of your day.